Hey everyone, and welcome to today's Explainer. We're diving into a genuinely mind-bending paper by researchers Noda, Koga, Husler, and Hashimoto. They are exploring this totally radical concept, the idea that art, music, and immersive physical experiences are quite literally revolutionizing how we connect with quantum physics.
Right off the bat, we run into the ultimate question for educators. I mean, think about it. How do you explain the unexplainable? How can we possibly teach a subject like quantum mechanics? It's notoriously difficult. It completely defies everyday logic, and honestly, it's just really intimidating. For decades, science communicators have hit this massive wall trying to find the perfect analogy or the clearest diagram to force understanding. But what if perfect understanding shouldn't actually be the first goal? Well, to see why traditional methods fail, we first have to understand the barrier itself, which is what we call the quantum intimidation problem. It's this widespread, deep-seated perception that quantum physics is just this distant, overly technical, and completely inaccessible field. When traditional explanation-focused communication tries to tackle this, it basically slams into a psychological brick wall. I mean, if you just start throwing heavy equations and complex jargon at an audience, their brains immediately go into defense mode. The learning stops before it even gets a chance to begin, simply because the intimidation factor is way too high. So, what's the fix? Enter quantum music.
And spoiler alert, it worked. Like, incredibly well. Over 4,000 people attended two specific initiatives analyzed in this paper, Quantum Fest in Japan and Quantum 100 in Germany. To put that into perspective, that is a massive crowd. And they didn't attract these thousands of people by promising a rigorous, dry physics lecture. Instead, they offered these immersive, artistic experiences. They used music, visual art, and actual embodied participation to create completely alternative entry points into the quantum world.
So, the crucial point here is the stark contrast between two fundamentally different approaches. On the left side, we've got the traditional explanation-centered model, right? It's conceptual, it's technical, it's very fact-driven. But on the right, we have this new resonance-driven approach, which is immersive, artistic, and experiential. And look, I know it's highly meta and honestly pretty ironic that we are using a structured, fact-driven explainer to talk about ditching traditional facts for an immersive, artistic approach. But the distinction here is absolutely vital. The researchers realize that while facts are obviously necessary, they just aren't always the best first step to get the public engaged. Okay, let's dive into the intellectual meat of this paper, the 3 dimensions of resonance. By analyzing post-event surveys and interviews, the researchers basically decoded why this artistic approach works so well. They laid out 3 specific dimensions of resonance. First up, sensory immersion and reduced psychological barriers. Number 2, collective embodied meaning-making. And finally, emerging transformative engagement. Let's actually break each of these down so we can really grasp the mechanics of what makes this teaching method so powerful.
Now, what's really interesting here is Dimension 1, sensory immersion. By wrapping these heavy quantum concepts in stunning visual art and beautiful music, educators physically and emotionally lower that initial intimidation barrier we talked about earlier. Think about it. When you're listening to a gorgeous piece of music, your guard naturally drops. The sensory experience literally sneaks the science right past your psychological walls.
Which brings us nicely to Dimension 2, collective embodied meaning-making. You know, traditional learning is usually such a solitary act. It's just you sitting alone staring at a textbook. But this resonance approach, it's deeply social. It's physical. It's about experiencing the science together in a shared space. When the audience participated in a collective event like Quantum Fest, they were using their bodies and their shared social presence to construct meaning. It takes quantum physics from this lonely abstract thought experiment and turns it into a vibrant shared human experience. Let's move to the final piece and see how this all builds up to Dimension 3, emerging transformative engagement. This is where the magic actually happens. That initial artistic hook, the music, the visuals, the shared vibe, it doesn't just evaporate when the event is over. Instead, it transforms into a genuine, lingering curiosity. The audience actively forms a lasting, meaningful relationship with the concepts. They leave the event not just feeling like they watched a cool show, but feeling a personal connection to quantum physics that makes them want to go out and learn more on their own. And that brings us to the ultimate takeaway, a new way to learn. And this brilliantly illustrates the paper's final conclusion. The researchers state, resonance-driven approaches enable audiences to form meaningful relationships with science before, alongside, or beyond conceptual understanding.
That is a profoundly huge statement. It means you literally don't need to perfectly understand the complex math to deeply connect with the science. A deeply meaningful relationship with a topic can exist before the rigid conceptual understanding is even there. The resonance acts as the bridge.
So, I want to leave you all with a final provocative thought. What if we stopped trying to just explain science and started actually letting people experience it? I mean, if a resonance-driven approach can make quantum physics, arguably one of the most complex topics in the entire universe, accessible and deeply moving for thousands of people, just imagine how it could completely reimagine the way we teach and learn absolutely everything. Thanks so much for joining me for this explainer. Keep asking those big questions, and I'll see you next time.